Acharya. Welcome to our new lecture. Today in C programming, I'm going to teach you linked lists. Yes, now this is the topic that will straight away lift you from an average student's category and put you right into that top 10% of the class. Yes, I'm serious. You hear of placements, you hear those big companies and give those excellent packages, and you hear of so-and-so student getting such amazing packages, and you wonder why am I not getting it? Because those packages are not for everybody. They are for the cream of the college, the top students of the class. And in programming, especially C programming, to put you in that category, you need to know this topic very well. So yeah, it depends upon you. If you are happy with that average job and an average career, and that's what you're looking at, don't look at linked list. Like 90% of students, they just skip it. They dodge this topic and move ahead. Yes, you will pass, you'll finish engineering, you'll get the degree. But that's what you'll be in that crowd. You want to rise above all of that and start your career with a bang, with an excellent job, with very good placement in big company. Know this topic very well. Now, what are linked lists? Linked lists are data structures. One second. So is an array. A data structure means anything that can hold a set of data. An array can hold a set of data. We've done so much programming using arrays. Yes, we all begin with arrays because they are very simple to use as compared to linked lists. I'm not saying linked lists are difficult, but it takes a lot of effort to understand it. That is why only a handful of people really know how to work with it. But it's like pushing a door. A door that's jammed. You keep pushing it. Many people give up. You see a little bit of improvement, but then you get stuck, you give up. But the ones who keep going at it, once the door opens, then it all becomes simple. It's just a walkthrough. That's how this topic is. See what all we're going to do in this discussion. First, I'll tell you what is the concept, which I'm going to do right now. I'm going to give you various examples, real world examples, all the structures, including this very video, which is being recorded as I'm teaching and is being sent to you and displayed. All of this is done using linked lists, and I will show you examples of it. Anyway, yeah, it's that much used. So first I'll tell you what is the concept. Then we will create a linked list. We will traverse through that linked list and display the whole list. This is the part where the door will finally open. This effort is what 90% students fail at finishing. They put their mind to it, but then because it is something that takes a long time to move, they don't have the patience for it, they give up. Once you cross this line, once you have displayed your first linked list, then all the other things that we're going to do will keep getting simpler and simpler, at the same time more and more interesting. I'll show you how to search an element in the linked list, how to replace an element in the linked list, how to insert elements and delete elements from a linked list. Now, where is all this used? What is the purpose of a linked list? Like I said, it's a data structure like an array. So if you know arrays, then why are we learning in linked lists? Why do we use them? There's such a meme that goes on all over the various social media. What are linked lists created for? To torture students. So they're not created to torture students. They are very nice. Look here. The first and foremost difference between an array and a linked list is an array is a static structure. I tell you, write a program to add some numbers. How many numbers? I don't know. The user will tell that. 5, 6, 7, 10, no problem. So what are you going to do? You'll ask the user how many numbers, that will be the count of your loop. You'll go on taking all those values, put them in an array, sort them, add them, find the highest. We've done all of those programs. But for that, in your program, you have to first of all define an array. The size of that array you have to keep such that it is bigger than any size that the user will give. So remember, in all our programs, for safety's sake, we say define an array of 10 elements or 20 elements or 30. So this is what you've done. You define an array of 20 elements. User wants to add only 4 elements. User has added 4. But what about those 16 spaces? They are wasted because you have created an array. Once an array is created, it will occupy space. Whether you put values on it or no, doesn't matter. It has occupied that much space in the memory. So memory is got wasted. Now for 5, 10, 15, 20 bytes, we are not doing all this. But think about it. Now apply the same logic and think about files. You want to be the person who's using apps, or you want to be the person who creates apps? Yeah, you want to create apps, then you're going to think much deeper. You're going to go inside the computer and understand how the operating system works. Now you're in Microsoft Word as an example. You have clicked file new. A new file has opened. Does Word know how much you're going to type? See, if you're very fast thinking, you already got the answer. How is a linked list different from an array? You may type just dear sir and end the file. That's it. You may type dear sir a few things and end the file. Or you may type a paragraph or a page or maybe 10 pages or maybe a whole textbook. Word doesn't know. But everything that you're typing, it has to capture that. And to capture it, it has to store it somewhere. Now, if it uses an array for doing that, by default, it would have to create an array of a very big size. You may type very little, and here the size is not in few bytes. Now it goes into kilobytes, megabytes, gigabytes. I start a video, like how I started this video. I don't know how long it's going to take. I never plan, there is no script. I'm just talking about things that come to my mind because you teach this, so you don't need a script for it. Anyway, so I don't know how long the video is going to be. Neither does the operating system knows. So when I clicked on video recording, iOS created a file. Now it is going on capturing frames. Each time I'm talking 30 frames per second, right? So each second, in this much time, 30 frames have been captured and added to the file, added to the file, added to the file. Does it know where it's going to end? No. So this cannot be done by an array. If all these frame information was stored in an array, do you understand how big the array would have to be? It's storing frames. The whole size of the file is going to go into gigabytes. It's going to waste so much memory. And what if I just record 10 seconds and cut it? I don't like the look of the video. I don't like something else. I cut it. Do you understand how much space that it had taken? It would have to then release it and free it and all that jazz. And that is rubbish. It doesn't work like that. The best part about learning anything related to computers is you are learning pristine, excellent logic, because this is not something that we have discovered. It was not found under some stone. This is all invented by us as in the best of the brains in the industry, applying all their mind and creating the best possible logic. So nothing that works in a modern computer is faulty or is low on ideas. So coming back, this is not introduced today. This was created years ago in 70s. See how wonderful this idea is. Instead of making an array, let's use a linked list. What is a linked list? A linked list is a set of data where each data is not just that data, but is also the address of the next data. That's it. Each element of a linked list is called a node. That node holds its own data. So each frame that I'm capturing will be stored in the node. The node is holding the frame plus is holding the address of the next frame. Till the time I don't press the end button in this video, it is just going to end. Till the time I don't press that button, the operating system keeps creating new nodes, captures a frame, stores it in the node, stores the address of the next node, captures the next frame, stores it in the node, stores the address of the next node. And this is how a linked list is formed. How long will it be? As long as I'm recording. Not one node more, not one node less. I may record 5 seconds or 5 hours, but it will create a file that requires exactly the size that it's supposed to be. Do you understand? So the difference between an array and a linked list is an array is a static structure, it's predefined. A linked list grows and shrinks on demand. In a linked list, every element is called a node. The node is created by using a function called malloc. I'll be teaching you that. Malloc means memory allocation. Every time, in every second, 30 frames have to be stored. The camera app is going on asking the operating system by running malloc, give me memory for a frame, give me memory for a frame, give me memory. All these frames, what looks like one video to you, may not even be stored in a continuous set of frames. Wherever it gets free memory pockets. Now, because I also teach computer organization, operating system, Pentium, 386, I know much more than what you need to know to learn this. So I'm not going to go so deep into the example that we forget the purpose of the video. But just because I know it, I just said that. So the app will keep asking the operating system for various memory buffers, memory pockets of memory. And at each place, the new frame is stored and a link to the next frame is stored. And this goes on happening till the time I end this. So first advantage is that it's a dynamic structure. Secondly, I have 100 elements, let's say in an array. Come on. I want to delete the 50th element. What does that mean? I go to the 50th element, knock it off. Now what happens to the remaining 49 elements? They stay where they are. There's just a free empty gaps created in the 50th element, but that's not how I wanted it to be. Now it should be only 99 elements, which means I'll have to shift these 49 elements above one by one, which is ridiculous. If you think this is how computers work, it is ridiculous. You know what does that mean? It means you're typing an SMS to someone, or a WhatsApp message, or any kind of message. You've typed a whole message, written a lot of things, and then you see a word written which you feel no, you're being a little too ambitious and you want to remove that word. So you go there and you knock that word off. What happens to the remaining message? It doesn't stay where it is. The message is not some text and then a blank space and some text telling the person, oh, something was written over here, but that person has deleted it. That's even worse than not deleting it. Anyway, so what happens is, whatever you deleted is gone and the remaining thing shifts ahead. Now, if you think this is done using an array, it's out of question, because that means I'll have to actually move all the data up, which is going to put so much overhead of programming. When you're editing any Word file or any message, things will just keep waiting in a loop and you'll get frustrated and you'll stop using all this. But computers are not made like this. Computers are made with a lot of intelligence. So instead of array, what is used dynamically also as you're typing to store all that data is a linked list. Now, in a linked list, there are 100 elements. You decide you want to delete the 50th element. No problem. I'm going to do it. We're going to do programs of it. You can see there is delete in today's lecture. So all you need to do is to delete this 50th element, link this 49th element, which was linking to 50th, just make it link to 51st. That's it. That's all. Nothing has to move ahead, nothing has to move behind. Just make this, which was pointing to here, point to here. That's all. And make this element or this node free. Just like when you do malloc, the camera app asks the OS to give memory. When you do free, the camera app releases the memory and gives it back to OS, telling the OS now give it to anybody else who needs it. That is why when you delete a video, you get space to record another video or store another app or store another game or whatever. You know, any memory can be used by any kind of application, because whichever application needs memory, asks the OS, uses it. This asking is done by malloc, and when its job is done, it does a free, which is the reverse of malloc, and gives the memory back to the OS. So we'll be using both, since I'm going to teach you insertion and deletion. So deletion is so easy. Just make this node point to this one and job is done. Now when the list is read, this is read, and it appears like all of these are moved up. Nothing is moved anywhere. It's just a game of pointers, just moving pointers around. Same goes with insertion. Think about it. There are 100 elements in an array. Array can hold, let's say, 1000 elements. You made a very big array and you stored 100 elements in it. Fine. Now what? You decide between the 50th and the 51st element, you want to put another element. What would you have to do if it's an array? I mean, it's so ridiculous to even think what could have been done. You would have to move all these elements one space ahead so that you can create space for storing this new element. It's like you typed a whole SMS and then you realize next to one word you want to add some emoji, or you want to add something extra, you want to insert. You go to that location and you hit insert. Everything moves. That's how it looks like. But in the memory, you're not going to really shift everything down. I mean, how can you think that's how it really happens? Instead, what we'll do is we'll create a new node. This node, which was pointing to this node, will now point to the new node, and the new node will point to this node, and that's all that's going to happen. That's all. And this is how your dynamic data structure grows and shrinks. At the top, at the end, in the middle, you can insert, delete wherever you want. You can search, you can replace, you can do a lot of things. So what do you think? As you go ahead in computer programming and you create complex data structures, there's a whole subject called DSA, where you make trees and you do a lot of things. What do you think you'll be doing all that with? Arrays, stacks, queues and all. You can create a stack with an array, you can create a queue with an array, but I just made you understand in that stack there are 100 elements. You want to remove one or you want to put one extra. An array will be such a headache. It'll be easier to create, but it'll be horrible to manage in terms of process and in terms of time, the slowness of your app. And nobody buys a program today if it works slow. Today's world is super competitive. Our country is releasing engineers by the lot, and the cream of the engineers. Every app, the way it used to run a few years back and you see the way it runs today, is phenomenally improved. It won't stand a chance in the market if it's slow. So you have to develop programming skills that not only make you get the job done, but get the job done in the most efficient manner so that your program works fast. Anyway, so that's the whole idea, that's the introduction of the whole topic. I want you to know this topic. I've seen generations of engineering students where, like I said, that number always holds true. First of all, a lot of people don't even know C programming, and the ones who know also, they know a little bit tidbits here and there. The moment in an interview you ask pointers or linked lists, that's the point, that's the moment of time when you differentiate between the ordinary student and the cream. You know which are the students who are really serious about programming, and if the job is related to programming, which 90% of jobs are, which come for placement, this is the criteria. This is what they may still pick you if you don't know all this. If they see talent in other things, maybe the other topics are so strong that you're capable of understanding, maybe you just didn't put the correct effort at the right time. But knowing this shows that you're serious about programming, and like I said, it just lands you that job on the table. Anyway, now the entire lecture and the whole course of C programming is available on my website, bharatacharyaeducation.com. The link is given down below. Click on the link, start learning. These are the courses that I've made so far. I know more. I will be making more. Some of them I've also redone in Hindi. That's all for later. Right now, the C programming course is complete. This is the last final, save the best for the last. This is the last video of this course. Click on the link, take the course, start learning. You know what all is there in the course. We start from absolute basics, running your first quintessential C program or displaying hello world. At that point itself, I make students in the first program very, very strong in terms of the output. You see the way the output is laid out. You should have total control about how you display your result. Your result may be 100% accurate, but if you have a shabby display with no alignment, no proper placement of things, nobody even feels like looking at that program. Today, UI UX is a whole department of masters. Do you understand? A whole department. Earlier, from being a small discussion to being a topic to being a chapter to being a subject, it's a whole department for doing MS. That much is the weightage given to appearance, because today we are living in a visual world. You don't use an app which doesn't have a good user interface, and you don't become a champ at that overnight. It starts right from the basics. I had learned a lot of this in the first job, the only job that I was placed through college, Infoban International. Anyway, I will not get into that. My boss, I owe a lot to that person for showing me how exactly and how well to display an output, which is so important as a part of the whole set of assets which a programmer has. Anyway, so I remember that, and I've been trained by him, so I always follow that, and I give that to my students. In the very first lecture where you're doing printf, that's when I want to give you complete command over printf so that you know how to display outputs properly. Then of course, teaching variables, all types of variables, doing programming, then teaching decision making. All that is done in the course. If, while, that single if, the single statement, if else, switch case, which is what you use when there are too many options in that if, and too many discrete options anyway. So all that is done. Then looping is done, for loops, while loops, do while loops. Then data structures come, arrays are done, single dimensional, two-dimensional arrays, matrix multiplication, very, very, very popular question, that's done. Then various types of loops, creating functions, passing parameters, passing pointers as parameters, pass by value, pass by reference, structures, then a whole topic on pointers, and now linked lists. So yeah, these are things that people learn in C programming. Everything, by now also you've seen the introduction, you know, everything that I teach is with a real world example, because I'm not teaching you something that you don't see happening. I'm teaching you programming, and everything we do today is related to some device where programming is done. So it's so easy to just pick up examples and relate. And I've seen when students relate what they've learned to what they experience in the real world, their understanding becomes very crisp and very clear, and becomes easier for them to write programs because now they enjoy doing it, because they know why they're doing, the purpose of doing that. Some topics take a little effort to do, but when you know the purpose behind it, the effort becomes easier. Anyway, I enjoy teaching, so I put all the concepts in the course. I hope to see you there. Wish you all the best. Do well.